to find the angle between our random vector and positive part of y-axis, we're going to use the representative vector j. So let us write this guy down here. The angle that the vector, random vector u, x1, y1, z1 makes with the positive side or part of y-axis can be found like this. So we're going to use a representative for y-axis, which is unit vector j, 0, 1, 0, and we're going to follow the formula for cosine. So now let us call this angle beta. Cosine beta is equal to u dot now j divided by the magnitude of u times the magnitude of j. Again, j is a unit vector, so the magnitude is equal to 1. Here we have y1 divided by the magnitude of u. So beta is equal to inverse cosine of y1 divided by the magnitude of u. We're following the same process to find the third angle, angle gamma, which is the angle that a random vector like u creates with positive part of z-axis. The angle that the vector u, x1, y1, z1 makes with the positive part of z-axis. Well, let's use the nice representative that we have for z-axis, which is vector k, 0, 0, 1. Here we go. Let's call this angle gamma, which is u dot k divided by the magnitude of u times the magnitude of k. Again, k is just a unit vector. The magnitude is equal to 1. So this is equal to z1, the third component of vector u, divided by the magnitude of u. So gamma is equal to inverse cosine of z1 divided by the magnitude of u. These three angles are called the direction angles. Now, let us go over one example. Write down these angles here. And take a look at one example to feel more comfortable about calculating these angles. So alpha, beta, and gamma, inverse cosine of x1 over magnitude of u, comma, the second component, inverse cosine of y1 divided by the magnitude of u, and inverse cosine of z1 divided by the magnitude of vector u. Example. Well, in this example, question says, find the direction angles of a vector A, which is given to us as 1, 2, 3, 1, 2, and 3. Okay, to find the direction angles, we're going to just follow the formula. Alpha, beta, and gamma are equal to. So alpha is inverse cosine of 1 divided by square root of 1 plus 4 plus 9. And beta is inverse cosine of 2 divided by square root of 14. And finally, gamma is inverse cosine of 3 divided by square root of 14. So let us use a calculator to find the approximation for these three angles, alpha, beta, gamma, approximately equals to 74 degrees. The next one, 58 degrees. And finally, we have 37 degrees. Well, another use of the dot product is being able to find the scalar projection and vector projection of one vector over another vector. We're going to see more applications of vectors in machine learning algorithms and also in linear algebra. Very well. This is our goal. Our goal is to create a new object. So we're going to have two vectors, and we're going to find the projection of one of them over the second vector. And it is actually a new vector. To find the projection of one vector over another vector. Very well. So suppose you have two vectors. Let A and B be two vectors. We want to find the projection of vector B over vector A. The projection of vector B over vector A can be calculated this way. Well, the formula that we're going to use, let's write down the projection of B over A. This is equal to, so we're going to use the dot product to find this formula. It is A dot B, the dot product between A and B, divided by, here we're going to use the magnitude of A and raise it to the second power to get rid of that radical, and you multiply that by vector A. So here you have your vector A, and the second vector is vector B. The projection of vector B over vector A is going to be this vector here. Projection of vector B